Okay, everybody, let's get started with this human landing system session. Before we do, thank you again to our day one sponsors, the Aerospace Corporation, Blue Origin, and the Boeing Company. So for this session, our moderator is Lisa Watson-Morgan, Program Manager of the Human Landing System at NASA's Marshall Space Flight Center. She will introduce the panel to you. So welcome, Lisa. Take it away. Oh, Lisa, you there? She's coming up. Hang on, she's bringing herself up on video.
Yeah, I think I'm here. Looks like my video is frozen. Can you hear me though?
We can hear you. So start talking and maybe it'll come up.
Okay, I turned my VPN off. Who knows? Yeah. Okay, well, I am Lisa Watson-Morgan, and I am honored to have an outstanding group of industry leaders on this panel. Each of the panelists are either program managers of their own right within their company or directors. So it's an esteemed panel with lots of experience. We have Nick Cummings of SpaceX, Robert Wright of Dynetics, and we have John Couluris of Blue Origin representing the combination of Blue, Lockheed, Martin, Northrop Grumman, and Draper. And so today I'm going to provide a high-level overview of HLS, and then I'll pass it back to Nick, and then Robert and John for each one of them to talk about their respective companies and to go over a few charts. And so with that, I wanted just to make sure that everyone was somewhat familiar with the Human Landing System. It is a broad agency announcement, and it's what we did is had a 10-month base period that started back we awarded 3 contracts in April of this year and signed them in May. And it is to take the first woman and the next man to the lunar surface by 2024. And not just to do it once, we want to have a sustained presence. And that's really important and key to the program and to how we wrote the requirements and set up this instrument. And as you can see in front of you, we have 3 substantively different designs, which, being on the requirements writing side and RFP development side, that's really exciting because that's what we wanted. We wanted to just excite industry's innovative spirit. And we wanted to see what can you come up with. And I'm just telling you, you can see here 3 significantly different options. Next slide. And so one thing that has been so much fun about working the Human Landing System is that we are very, very, very fast paced. And we were talking about that this morning, actually. It's kind of a daily thing. We are just in time. We are working so hard right now through the base period. You can see all the items that led up to the base period. Over the summer, the end of summer, we had what's called a certification baseline review. It went exceptionally well. Leading up to that, a 15-week period to where we had the requirements, the design and construction standards with the technical authorities, the chief engineers, the health and medical personnel, and the safety and mission assurance personnel. And so all of those standards of all the years of the best of what NASA's corporate knowledge of how to build things. We worked that collectively with each industry partner to come up with a unique set of standards for each one to move forward with that best met their corporate culture and their needs. Along with NASA's obviously goal of getting to certification of flight readiness and being able to safely fly humans. And so that was incredibly successful. And now we're preparing for the continuation reviews. And the continuation review is really just that. It is the review that is going to determine, which 2 we get to move forward with. And having 2 partners join us in this endeavor to land humans on the moon again in 24 is just quintessentially important. And it is because competition, U.S. industry competition is it's formidable. It's exciting. It's it reminds me of Apollo. So we had a charge, for Apollo. It was a race and it was a competition. No bones about that. And the U.S. was first to land, and so having two U.S. industry partners competing for that first slot to go to the moon will get us there faster. It will bring out more innovations, and we will see more technology growth. And we truly believe that. So the first, after we award in the spring for those two providers, the first provider will fly up to Orion to accept the crew in 2024. And then in 2025 is when the second provider will launch. Next slide. And so we're not just going for the 24 mission. That's one thing I would definitely want to make clear. In what we're working on now for option A, which will be the next phase of the procurement, we are going with with the plan to stay. And to do that, then we have to overcome lots of obstacles and lots of challenges, like extreme access issues. So we're going to the lunar South Pole, and so we will have to get to where we have mobility available to us. Lunar dust is ubiquitous, and it's that charged material, the regolith, and it adheres to everything, suits, the lander itself. And dust mitigation is going to be a key issue for us over time for our sustained missions. Obviously, the crew is going to have to be able to survive in these extreme environments. And obviously power, when we are in darker regions, because we really do eventually want to study those permanently shadowed regions of those giant craters, because that's where, we haven't been before with humans. And that is a really exciting part of our mission. Next slide. And so the human landing system is launched uncrewed. We do not have crew on us when we launch. We are launched as a large commercial payload. And these providers proposed end-to-end solutions, launch vehicle, lander, everything. And that's what the human landing system's role is. It is to go up to near rectilinear halo orbit and wait for our national capability of the Space Launch System, Orion capsule, and Exploration Ground System to deliver crew to that NRHO orbit. And at that point, that's when HLS and Orion, and then in the future for the sustained missions, Gateway, will dock, and the crew will get onto HLS, and then we will perform our missions. So really exciting stuff. And this is just a real high level overview. We could go 45 minutes on this, but I want to hear more from each one. And so with that, let's go to Nick.
All right, thank you very much, Lisa. Let's see, I have hearing some very bad echo. If we could bring the slides up.
Nick, you're muted.
Okay, did that fix it?
Yep. No echo, go.
Okay. Yeah, so transporting large numbers of people to live on the moon and Mars is the founding purpose of our company and guides everything that we do. The vehicle that we're building to enable this future is Starship, and we're excited to be working with NASA under the Artemis initiative to land the first woman and the next man on the moon, along with many, many more women and men to follow. We're building on the achievements of Falcon 9 and Falcon Heavy and Dragon, as well as on the lessons from the Space Shuttle program and other NASA vehicles in developing Starship, which is going to be a mass-produced, fully and rapidly reusable super heavy lift transportation system. And that mass production and rapid reusability is going to help us dramatically reduce cost. So if you stop and think about it for a second, just a few years ago, it would be unthinkable to say that you could have a mass-produced super heavy lift launch system, or it might be equally unthinkable to say that you could have a fully and rapidly reusable super heavy lift launch system. And with Starship, we're going to have both. And we think that's the key to making it affordable enough for large numbers of people to live on the moon and Mars. So all of this is coming together at SpaceX's site in South Texas. If you could go ahead and click, I think this is a video to play. Okay, so that was a 150-meter flight test of Starship serial number 6, which we did last month. In that flight test, the Starship prototype was powered by a single Raptor engine. And as I said, it flew up to about 150 meters. So just this year, we did a similar test with Starship serial numbers 5 and serial number 6. We also completed cryo-proof testing to burst with serial number 7. And we've done a number of static fires and other tanking tests along the way. So now what you're seeing here is serial number 8. This is on the pad getting ready to fly to 15 kilometers. And you can see this beautiful image with the sun setting in the background is of the nose cone being installed, which was completed late last week. So during this flight test, serial number 8 is going to be powered by 3 Raptor engines as opposed to just the one that flew on serial number 5 and serial number 6. And we completed a multi-engine static fire testing about a week ago. I think there's some video out there online of that. So you see there, differently than the kind of flying tank configuration that we had in the last ones, you can see a nose cone with the flaps installed. Those flaps are not just for show. The tests, starting with this serial number 8 flight test, we're going to go much, much higher, up to about 15 kilometers. And we're going to test out Starship's atmospheric flight and control capability, which is extremely important for reentry and most importantly for the safe landing after reentry. And meanwhile, we also have Starship serial numbers 9 and 10 in production. So if you look back over the last year, it might seem like we've been averaging a build rate of about a Starship a month, which is pretty impressive. But the cool thing about it is that the rate has actually been accelerating and is going to continue to accelerate. We've also built around 50 Raptors, and that rate is increasing as well. We've also started production of our first super heavy booster, and we're on track for our first orbital flight of Starship next year. So to do the orbital flight of Starship, we need both the super heavy booster and Starship. And we have that first booster in construction right now. And changing gears, we have probably our most important responsibility of all, I would say unquestionably our most important responsibility of all, which is the Crew 1 launch coming up next month. And we're very, very humbled and awed by the responsibility to be transporting NASA and international partner astronauts to and from the space station. And we're really excited to have more flights coming with private astronauts as well. The Crew 1 milestone's absolutely relevant to HLS because we are not only advancing our crewed flight capabilities, but we're also really pushing commercialization in low Earth orbit, which is ultimately part of NASA and our objective, shared objective, I think, of increasing commercialization in LEO so that we can move out to cislunar space into Mars. That's all I have. Thanks, Lisa.
Thank you. Thank you, Nick. Okay, so Robert, if you could take it next, please.
Okay, Lisa, thank you very much. For those that don't know me, I'm Robert Wright. I'm the program manager for Human Landing System for Dynetics and our team. I believe I have a chart or two, if those could come up. Thank you very much. Yeah, so on the next slide shows our lander on the surface of the moon with a few crew around the lander. I'll wait for that slide to come up. Next slide, there we go. Yeah, so I just really wanted to highlight, that our overall approach to the human landing system as we move forward really was to bring together a team of proven companies that have expertise in various aspects of human spaceflight and hardware, and also while partnering with NASA and through collaboration and the government task agreements that NASA offered for us to take advantage of, to really be able to bring together a collaborative team to develop an innovative lander as shown pictured here on the screen now. You can see that in our approach, right, we've really tried to address the crew-centric nature of the operations that need to be performed on the surface of the moon. And again, not just for an initial landing capability, but for ongoing operations, extended duration operations, and then be able to support going back multiple times. That's why, again, we approached our architecture for a reusable architecture. So what you see on the screen here, we refer to as the descent-ascent element. It makes the transition from lunar orbit down to the surface of the moon. The crew there for 6.5 days for the initial mission capability. And then as they return back to lunar orbit and rendezvous with Orion, the descent-ascent element stays in lunar orbit and just awaits new tankers to arrive to refuel the lander, and then we can complete subsequent missions over and over again with the same lander vehicle. So again, key to the sustainability of returning to the moon we believe is reusability. Again, reusability we think leads to sustainability and ultimately leads to a lower overall program cost and operational cost for the program. Again, not just for the initial mission, but for the many missions to come after that. This is the architecture that enables a commercial market to actually develop in the lunar space and allow many missions as we go forward. So as what's shown here on this picture, again, our Dynetics vision of, again, not just landing on the surface of the moon and performing initial mission, but being able to use the lander to support, crew landings and a variety of cargo, be those habitats or rovers, power stations, certainly science and science payloads. There's just a wide variety of missions and that can be executed once the basic transportation system is in place. And we've approached our lander design to be able to support both crew and cargo missions over and over again for a long time. And so that's all the slides I had today. I'll pause there and turn it back over to Lisa.
Okay, great, Robert. Thank you very much. And we'll wrap up the intros with John. John, if you would go ahead and start, then that would be great.
Great, thanks, Lisa. So I'm John Couluris. I'm the program manager for Blue Origin from the national team, representing Lockheed Martin, Northrop Grumman, and Draper, as well as a number of our partners. Thanks for having us today. We're very excited about our architecture. As you saw in an earlier video, we're broken up over 3 elements: the ascent element built by Lockheed Martin, the descent element built by Blue Origin, and the transfer element built by Northrop Grumman. Draper is also an important partner, providing their years of experience on terrestrial and other world navigation and guidance, navigation, control, and avionics as well. What we like about the 3-element architecture is we're really leveraging the best of all our partners. On the descent element and the transfer element, we're pushing the technology envelope with a liquid oxygen, liquid hydrogen system. So we're really looking forward to not only getting that first mission to the moon as quickly as possible, but also the sustaining elements, utilizing lunar resources to ensure that we enable the cislunar environment for humanity's long-term stay on the moon and in orbit around the moon. The liquid oxygen, liquid hydrogen system is based off our BE-7 engine. We have 2 on the descent element and 1 on the transfer element. We also utilize our cryofluid management systems. I'd like to also just give a thanks to Marshall. All of our engine testing for our HLS solution is occurring on Marshall Space Flight Center grounds. And it's enabling us to quickly move forward to mature technologies, drive TRL levels so that we can have a sustaining effort here. And it's important because the base period of the HLS program has really been allowing us to mature a lot of technologies so that the country can make the proper informed decision as to a winner to move forward or winners to move forward for option A. The ascent element is leveraging a lot of already proven Orion heritage in crew training, in avionics, in systems. So across these 3 elements, we're really trying to push forward to get us to the moon as quickly as possible and sustain. Within each element, we also have modular upgrade capabilities. So within the elements, we'll be upgrading certain subsystems to adapt as we not only learn in the lunar environment, but as we push technology forward. It's very interesting again today, as you saw the announcements from the Sophia crew from SMD, that water has been detected in sunlit regions of the moon. So again, being able to have the flexibility to utilize lunar resources is critically important to us. If you go to the next slide, please. And Nick, I commend you on proving that Zoom can display videos. I would like to guide everyone to YouTube. We just had a successful 100-kilometer firing of our new Shepherd vehicle with a number of our sensors on board, our terrain relative navigation system, as well as 2 LiDAR systems. We use that in a data collecting method so that now we will be able to navigate and prove that we'll be able to navigate not only to the initial regions that we want for a landing on the moon, but for eventual precise landings to any location on the moon. And that's what really makes kind of this solution, in our opinions, one of the most forward thinking as far as how do we get there and how do we stay on the moon. And so in this image, you can see after landing, the crews descended down to the surface. The descent element is also capable of cargo operations. And in fact, we'll be flying the descent element in the 2023 timeframe as a pure demonstration vehicle. So we'll land that on the moon in 2023 and utilize any lessons learned from that to inform our first crewed mission to bring the first woman and next man on the moon. Thank you very much.
All right, so now we're going to go to the Q&A, and I would think everybody probably needs their cameras on. And so we're gonna start with Nick. And so my first question is, and I would like everybody to answer this. So how do you think having government and industry working together to achieve the human landing system mission might impact the future of the space industry and space exploration? And so what changes, if any, do you anticipate as a result?
Well, Lisa, I think if history is a guide, if we look back at programs like the Space Station Commercial Resupply Program, the Commercial Crew Program, NASA's Launch Services Program, I think they're good parallels. And these programs have shown that when the government sets high-level objectives and lets companies compete for firm fixed price contracts for services and systems that they also market commercially, everybody wins. Prior to the COTS program, the United States had completely lost the global commercial launch market. Launch prices were skyrocketing. NASA science programs were seeing more and more of their budgets going to launch instead of to the science instruments and spacecraft and new technologies. And the COTS program turned all that around, driving the cost of space launch down and eventually catapulting the US back to leadership in the global commercial launch market. So I think with us keeping this partnership model at the center of our deep space exploration program, we're going to keep seeing how NASA can efficiently contract for services that meet their needs while also advancing these broader economic and strategic objectives that really enable sustainability. So I think that efficiently and responsibly executing this program, a deep space human exploration program that addresses enduring broad national objectives is really the key to sustaining an effort of this magnitude. And frankly, that's something that we've struggled with in the past. So I think that's going to be one of the biggest changes in a nutshell is long-term sustainability and viability of the program and how much value we get from what we're investing.
Yeah, thank you, Nick. I agree. It is an exciting partnership with all three of the industry partners. It has been really exciting for NASA to watch how each one of the partners, how they operate and the culture. And I agree with you, definitely that having some continuity and some time and you know, knowing that we're going to get funding or we are supported and we, you know, will make this run for the nation. I think I agree with you. It's very important for us continuing. Okay, so now, Robert, so how do you think having government and industry working together to achieve the HLS mission might, you know, impact the future of space industry? If you could go ahead, Robert, and address that one, that would be great.
Sure, Lisa. Yeah, so first, I just wanted to recognize that I think industry and NASA have been working together for the decades that lead up to this time to accomplish great things. I think we can look in our past and we can see where that has happened and where that's been effective. But as Nick pointed out, I do think that it was pivotal with the commercial resupply and commercial crew programs that NASA and industry demonstrated that there are alternatives to the way that major systems can be developed and operated and how they're serviced, and that's what is obviously being proven out on HLS right now. Again, as you highlighted in your introduction, when you look at the work that we have done just in the few months that we've been working on the base contract, we've made all the teams have made significant progress. We've made a tremendous amount of progress in getting through the initial reviews and setting the stage for the development to come ahead. And so again, I think that the approach that's been taken with the BAA and the structure that's been put in place has certainly provided an opportunity for alternatives to be explored and to be demonstrated, that teams can approach things from slightly different directions and achieve, common goals, not just for NASA, but for the customer base by and large. And I think that's what's happening right now. So again, I think the approach that has been laid out is showing that there is more than one way to develop systems and operate systems, that it can be flexible for NASA being a customer versus just an owner of solutions or systems, and then enable the commercialization of solutions to customers beyond NASA alone to allow industry to provide those services to a broader range of customers around the globe. So I think it's an exciting time, and I think HLS is really setting the groundwork for how developments of other capabilities and systems should be developed going ahead. I will also say, though, I think there's not a one-size-fits-all approach. I think, again, when you look at the broad range of, how the government, buys and either products or services, both, that there's a range of solutions here And I think the exciting thing is that commercial resupply, commercial crew, and HLS are demonstrating that that different alternatives can provide successful results.
Okay, thank you. Yeah, I agree. I do think when government and industry works well together in a multitude of different ways. I mean, we've had lots of successes over the years with other, contract types and mechanisms too. Okay, John, how about you take this one, and then maybe we'll hand it over and see if Jim has any questions from the audience.
Sure, thanks. So, yeah, first of all, as is mentioned, competition is critical in order to ensure that the country gets the best product for the lowest cost and for the best schedule. And that's been proven time and again. Just like what was mentioned earlier through COTS and CRS, along with our partner Northrop Grumman on their Cygnus vehicle, we've been able to prove that a multi-vehicle attempt or approach to solutions is critically important. And it's more than just that, because this is a competition not just among companies, but it will be globally. So we want to make sure the United States is ready for that and moving forward, and we welcome that competition. And regarding government and industry collaboration, it's not either or, it's really both. And that's what's exciting. Just like how NASA and government kind of opened up low Earth orbit to commercial operations, first crew and then cargo. And now that's being really explored, and the market will determine what will be the best utilization of low Earth orbit. Is it commercial orbital halves? Is it more exploration? We will let the market decide. Now NASA has moved on to the moon, where we will be following in commercial footsteps, and then same for Mars and beyond. So competition and a government industry partnership is critically important. And that's what will really allow this attempt to be so successful for HLS. And like was mentioned earlier, you can see that we have three completely different kind of approaches how to get there. And it's going to be exciting to see how we are able to accomplish this. And there's, again, to reiterate what Robert said, there isn't perhaps just a one size fits all. So again, very excited, and we're looking forward to the option A selection process.
Yeah, that has been really exciting, and it has come with some interesting issues too to overcome, and of course, just in time. Pulling on something that you said, a country that can come together, and especially now with, commercial industry partners, send humans to another celestial body to walk on it is really a force to be reckoned with. I mean, it sends a message that not only could, we do it with with the government heavy involvement. I mean, the government is still very much involved in this, and we're taking steps to start handing over, just like we have been with LEO, to start enabling commercial to grow more as we do further and deeper exploration. So I think that says a lot for the nation. It says a lot for aerospace and all of our partners. So, all right, well, great. Well, so we'll do one more question, and then we'll hand it over, and because I think the audience has some questions, of course, that will be exciting to answer. So the second question, and this time we'll start with Robert. So Robert, we'll start with you, and then we'll go to Nick, and then John. So NASA is going to the moon to land in 2024, and that is incredibly fast by any standard, because it's 2020 right now, and we are in a pandemic, and we have kept every single milestone, and we've kept everything on schedule. But so in addition, we also, as all of us have mentioned, we have plans for lunar sustainability, meaning we're going with a plan to stay on the moon. This, we want to have a sustaining presence. So why is sustainability important to space exploration, specifically, to these moon missions?
Yeah, thank you, Lisa.
So Robert, if you start, thanks.
Yeah. So we've touched on the topic of sustainability already in our session, but let me highlight that we believe that it's really vitally important to the overall, ongoing success of the program. Having sustainability, which again, second to, well, first and foremost, crew safety, right? Sustainability second, has really been the hallmark of our entire approach for the lander system and our vision for the development of the lander and how it's used and operated throughout. I've already mentioned reusability. We believe that the reusability of the lander, right, is a key element towards sustainability, right? Because ultimately sustainability leads to lower operating cost. Lower operating cost, right, allows you to do more with the critical dollars or the limited dollars that you have, regardless of who the customer is, right? Whether the customer is NASA or private industry. And so, again, approaching the lander system with the goal of reusability and being able to go and use it over and over again. We all know that, again, in the free market enterprise, right, that demand lowers prices, right? And so doing something one time costs, a certain amount of money, but doing it 10 times, leads to efficiencies in costs and operations that you're allowed to spread out over, multiple uses and repetition. So again, I think demonstrating that sustainability, I think having sustainability as a key element for going back and going over and over again allows us to be able to set the proving ground for operations on the surface of the moon. Because again, there's clearly a tie between going back to the moon and living and working on the moon and the goal that the society and the nation has for going to Mars. We know that the mission to Mars is a priority, again, for society and for the nation. But as tough as the moon environment's going to be, the Mars environment's going to be, that much more challenging as well. And so providing a transportation system in order to be able to allow the astronauts and Americans to live and work on the surface of the moon and demonstrate that will pay dividends toward us learning what we need to do to architect a transportation system that supports going to Mars, performing science, collecting samples, and returning humans back from the Mars environment. So again, we think that sustainability in the lunar environment is absolutely an essential element to achieving the long-term goal of sustainability in the Mars environment when we head out in that destination.
Yes, thank you, Robert. And pulling on that sustainability, we talked about it earlier too, but really the, starting and then stopping and having uncertainty is obviously very difficult for any type of complex, unique program, and certainly something that we haven't done in so many years. So I think, having that sustained funding and backing is also really important. And so, Nick, if you want to address this one.
Sure. I certainly agree with Robert and with you about the importance of the intersection between sustainability, lunar exploration, Mars exploration, and Lisa, I think to your point, the key to that longer-term sustainability is addressing broad national objectives that don't change, whereas, kind of near-term goals sometimes change, funding environment's always changing. Those broad national kind of needs and objectives don't change, and so we have to be addressing those. When we think about humanity's desire to explore, both to learn, to live in new places on Earth, has been critical to to the advancement of our species so far. And so I think living and exploring exploring other planets and living on other planets is really fundamentally about enhancing the long-term prosperity of humanity. And it's that type of enduring objective that I think makes big initiatives sustainable. So from space exploration, we get excitement and adventure. We get motivation of people and kids to pursue STEM careers. And we also get those science and technology benefits that pay significant dividends back here on Earth. So if you think about it, it took less than 50 years to go from Lindbergh's first transatlantic flight to land humans on the moon. But in the 50 years since, only 24 people have been back to the moon, or have been to the moon in all of history. And we haven't landed since, I think, 1972. So I think the key here is that we really need to accelerate progress if we're going to pay those benefits to ourselves and to our children and to their children. And so, as the administrator has said, we want to return to the moon sustainably, meaning we want to be able to sustain a human presence on the moon while we also press on to Mars, right? So it's about achieving and paying those broad national objectives, really even global objectives that apply to everybody, by accelerating progress and then sustaining that progress. So when we think about what we're going to need to do in order to establish a toe-hold off planet, I think I like to think of analogs like Everest Base Camp or the McMurdo Research Station in Antarctica, where you have sometimes up to more than 1,000 people living, depending on the season. And by comparison, the space station only supports a handful of people. Yet it's more than 400 tons and has required hundreds of tons of logistics to be delivered over the span of its life, plus over or nearly 100 crewed flights. So a challenge is, how do we build and sustain an outpost on the moon to deliver, requiring the delivery of all of these hundreds and thousands of tons of supplies, while also moving on to Mars? And I think that comes back to having a really massive breakthrough in the affordability of the transportation system. And that's what we are striving to do with Starship, and striving to make that system both completely relevant and applicable both to lunar transportation and Mars transportation. So that's how we think about it.
All right, thank you. Okay, so John.
Sure. So again, echoing what was just discussed, the criticality of sustainability is very understandable. The fact that we need to enable humanity's ability to stay and thrive in these environments will allow us to grow beyond. For example, on our BE7 testing that we've been doing, we're not only looking at that for what is our current performance, but we're looking at things such as what, if any, refurbishment would be needed for multi-missions that are in an environment that don't perhaps allow for refurbishment in close proximity. So we're trying to think beyond just the initial sustainability of propellants and of resources, but how are we making this entire system truly enabled to stay within the environment? We think about ISS as well. The lessons learned from ISS that are now allowing us to progress to the moon and to beyond are really important, because there are great lessons learned and great lessons again through COTS and CRS, and again through shuttle, that we're now able to apply. I'd really reiterate that sustainability also is part of a national will. We've talked about STEM and the encouragement of the future engineers and future managers of the country and the world to continue on. But there's also sustainability within government. And that's what's very exciting, is that right now people agree that this should be a national imperative, that we should do this. And so to avoid the start-stop nature of past programs, that in itself is a sustainable national effort that will allow us to get to the moon and stay there. So I want to be respectful of people's time. I know we're a little tight on question and answers, but I'd welcome asking further questions on it, because again, we can't make this a one and done kind of thing. We have to go to stay. That's in all of our DNA.
Yeah, well said. Yeah, well stated. Okay, so I don't know, Jim, I think we may have had some questions from the audience. I certainly have a bunch more, if not, but we're happy to address some from the audience.
Yeah, we definitely have some audience questions, including some of our media friends. So let's get started with that. Jeff Faust asks, talking of sustainability, this is fiscal, financial sustainability. What happens to the HLS program in 2021 if Congress provides only the $600 million the House appropriated versus the $3.2 billion budget request?
Okay, well, I'll take this one. So, you know, right now our base period goes through February 28th, and we are funded to complete all the base period milestones required for this, you know, for this period. So we're good for that. We certainly have planned some interesting methods that we could use because we do have a broad agency announcement. There are a couple things that we could do to try to extend maybe a month or so. That's an option. So we have some flexibilities. The problem is going to be trying to, you know, if we delay award because let's just say we, you know, are still on a continuing resolution and, you know, we haven't received the funding that we need. Well, you know, we could delay month by month, but then, you know, these partners, these industry partners that you see here, they have other work that they're going to have to go off and do that they're getting paid to do. So it's important that we match up both, you know, the funding and the work to make sure that we can continue this progress. So we're definitely good through February, and we have some plans. Should we get some maybe news like what you mentioned, Jeff, but we are certainly also planning to get additional funding so we can achieve the moon landing in 2024.
Great, thank you, Lisa. That's, I think, the answer that he was looking for. So from another one of our media friends, Irene Klotz at Adweek, totally different topic, but for all panelists, maybe with the exception of Nick, for obvious reasons, have you selected a launcher for HLS? So John, Robert, have you guys selected a launch provider?
I'll start. So for competitive reasons, of course, I don't want to name names specifically, but we have designed our vehicle to allow as much flexibility in launch vehicle selection as possible. And that's not only for this initial mission, that's for follow-on missions. So just like we talk about how important competition is, it's important throughout the program. And that's all I really want to say about that. Hopefully after award, we can talk more about it.
Yeah, and so I do want to just preempt. I'm glad you answered it like that. That's why I knew you do. But you know, and I think most of, hopefully, I'm pretty sure most of the media is aware. But you know, so since we are still in a competitive mode, there's only a limited amount of information that is publicly available because you know, we want to make this as fair and honest a competition as possible. So, you know, with that, you know, next spring, you know, we should be, you know, wide open, ready to tell all, share all. But go ahead, Robert, if you want to answer some of it, and I know for, you know, competition reasons, we certainly, you know, don't have to.
Yeah, so I'll just add that, you know, we've already publicly named the partners that we're working with in the public forum. So again, certainly those can be that information can be found there. Again, we see launch, right, as a critical platform, right, enabling the overall mission. We continue to look for the opportunity to obviously to take advantage of the Space Launch System. Should the Block 1B vehicle development proceed and come about. We think there's some unique opportunities that Block 1B provides when that matures. But yeah, as you stated, we are in a competition. We're responding to requirements of the draft BAA, and there'll be a lot more information to come.
And
Okay.
Jim, if I could jump in,
oh.
it might,
Yeah,
just
go
in
ahead,
case just in case it's not obvious to everybody in the audience why, why you mentioned that about us. So Starship is a fully integrated launch and landing system. So the Starship vehicle serves as the second stage of the launch vehicle, and then is the same system that then lands on the surface of the moon or on the surface of Mars. So I just, for anybody in the audience who may not be familiar with the architecture, that's why the question about selecting a launch partner maybe wasn't as applicable to our solution.
Got it. Glad you said something, Nick. I didn't want to leave you out there as the only one not talking. So this question, can you describe plans for accommodating astronaut EVA suits? And respect to that, what about dust mitigation? What have you thought about that for in and out of the HLS?
Sure. I'll start with it and just provide a little overhead, and then if anybody wants to jump in from the panel, for sure. So, the Gateway program is responsible for our EVA suits, and we work very closely with Gateway, with the program managers, as well as the EVA community, to try to do all that we can to get the suits, lighter. And they're more flexible now. They're going to allow a lot more mobility, which is going to be really important, especially as we're trying to get into some of those craters and do the science and certainly for the sustained missions. So we are providing, NASA is providing that's something that the government is providing to each of the partners. And as far as dust, so the government is also working risk reduction efforts around, dust mitigation. We're working plume impingement to see how, the dust, comes up. And so we're working a lot of different facets of dust at different NASA centers. We have some of the work at Kennedy. Some of the work, we obviously have a lot of the health and medical community at Johnson. We have personnel here at Marshall Space Flight Center. So we have a lot of the different centers involved in it, but each one of the partners also have, are contributing different thoughts and ideas moving forward. And if any of you want to jump in and talk about it, you can. Again, since we're in the competition mode, it's up to you.
Yeah, Lisa, this is Robert. If I could, I'll add that, again, dust mitigation is something that we're looking at across the entire lander system, both relative to the exterior of the vehicle and the protections and mitigations that we need to take for the operation of the vehicle itself, but then also relative to the crew and obviously with the EVA activities, bringing dust back into the crew module and being able to address dust concerns as far as bringing dust into the crew cabin. The crew compartment. So that's been one of the focuses that we've had relative to the interior layout of the crew module and making accommodations for that in order to try to control the dust and the migration of dust around the crew module to give the crew, the best possible living environment for extended durations on the surface. So again, a lot more information to come, but that's certainly something that the team's working very diligently to address.
Yeah, I'd like to add on.
Oh, John.
I'm sorry. That we've exactly like Robert has spoken to. We have a science advisory board that's been looking very closely at this effort, as well as going through some tech maturation efforts to get ahead, to inform our design as early as possible. So again, allowing this base period that NASA has formulated to inform our designs as much as possible. And again, because of competitive reasons, we obviously want to be careful, but dust mitigation, human interfaces, human factors, the lunar environment itself have been top priorities for us to be able to tell that story of how we'll be able to mature this. And again, our demonstration missions will help mature even further a lot of these discussions of lunar environment operations. So we're looking forward to continued discussions, and the multiple NASA centers have been very helpful in that.
And then from our perspective, to the original question, accommodating the EVA suits is definitely we have quite a bit of space in Starship to accommodate those. And then relative to dust, one of the things that we're doing is trying to keep the lunar dust out of the cabin in the first place. So we use airlocks to effectuate that, which allows us to kind of keep the dirty suits and crew equipment out of the habitable volume of the lander vehicle. And so the idea being kind of more like when I take my kids to the beach, you know, I try to get their suits and the sand off them before I get them into the car, because otherwise the car gets full of sand and then there's nothing you can do about it, right? So that's our approach.
Got it. Thanks, everybody. Okay, so this question comes from Daryl Shuck. John, you mentioned a 2023 uncrewed mission. Dynetics, SpaceX, are you planning similar uncrewed missions to test your vehicles? And if not, what kind of testing are you doing?
Yeah, you want me to go first, Robert?
Okay. Yeah, I'll jump in.
Go ahead.
Glad to. So yeah, we are planning an uncrewed mission. We have it in our planning as we go forward, looking at late 23, early 24 to demonstrate the landing system on the surface of the moon. So yeah, that's part of our baseline plan as well.
And yes, we anticipate flying Starship many times to orbit and on other types of missions before the initial crewed landing mission. So we're absolutely looking forward to landing a Starship on the surface of the moon and demonstrating that capability uncrewed prior to doing a crewed lander. Maybe we'll even do it more than once. We'll see.
Yeah, I'd like to follow up as well. Blue Origin has been working the Blue Moon program for over 3 years now, specifically for a lunar mission. The demonstration mission was an outgrowth of that. We've been working that over a year, not only within the company, but among the national team. So with Lockheed Martin, Northrop Grumman, and Draper participation. And so that's why we're really pushing that this demonstration mission do more than just show that we can get there in 24, but what other technologies can it fly that also allow a sustained presence?
Okay, great. So we're just about out of time. We have about 1 minute left, but so Lisa, I'll take executive privilege here if I could. And lightning round, this is my favorite thing to do. So starting with Lisa, let's go Lisa, John, Nick, Robert. Lisa, what's keeping you up at night?
Well, of course, the budget. What else would keep the program manager up at night, right? It's the speed at which we're moving. We're making decisions really fast and working so hard. I will tell you, we won't be late because of us, that's for sure.
Yeah, actually, I hate to concur, but because the budget is such a major portion, it's part of the natural resources that go into such a program. But what I like about it, and when we say keep you up at night, is the ability to think of ways around, okay, if we have this budget scenario, what can we do? If we have that budget scenario. And so that's also the exciting part, is how can we get the best bang for the buck, if you will, here with what we're able to get from the budget environment. So it keeps us lean, it keeps us scrappy as well. Now, I'm not saying therefore we should go with even more decreased budgets, but I'm very pleased with what the team's been able to do so far.
Nick.
Let's see. The easiest answer is probably Lisa's deadlines keep me up at night. But in all seriousness, and she knows I'm only half joking about that. But no, in all seriousness, you know, we've taken on an incredible challenge with Starship. Again, the full reusability of the vehicle, and then really that mass production. So ramping up that production rate to achieve that affordable high flight rate is, I think, one of the biggest challenges that we're focused on right now.
Robert.
And I'll just finish up. by saying that, I think design complexity, right? Again, this is a complex system of systems, right? And so you want to make sure that you've got enough time to do all the analysis and to do the tests that you want to do to make sure that we're developing a safe system for our crew. That's something that definitely needs to be paid attention to, and it's something that you got to stay on top of. And then secondly, the budget. Clearly, having the country's backing and support, having bipartisan support is huge. We're on this is the right mission, this is the right goal for NASA, and having the funding to allow the teams to do their good work and their due diligence and continue forward, that's a priority.
Gotcha. Thanks. Okay, so one quick last little thing. Irene Klotz asked if you had selected a provider, not who. So she just wanted to make sure we had that clear. That was on me. That was my fault. So unless there is anything else, we are out of time. So thank you very, very much to all of you. Great session, great panel.